there is nothing complex in Bitcoin, blockchain, NFT, and so on. There is nothing complex. In this video, I'm gonna build for you all of this stuff using Excel and the 7-zip. Well, 7-zip is, if you don't know, it's like WinZip but free. So also we use Excel because I expect you to be familiar with, and it's quite friendly to what I have to do. But in principle, you might use Word, you might use Notepad, you can use even, I don't know, Paint, or even write on a paper, because we needed to write some numbers somewhere, right? You can even write literally on paper and pen, and then take a photo with your phone. Doesn't really matter. I use Excel just because it's more convenient. And you will see, it's really simple. If you're watching this video to get some suggestions how to invest your money, oh Damiano, you work in a bank, do you suggest me to invest here and there in Bitcoin? Well, this is not the aim of this video, but okay, I will give you my opinion about investing in Bitcoin in a random moment during this video, so you have to watch it all. Yeah, you have to pay a price. Anyway, as I said, there is nothing complex. Of course, if you want to implement a Bitcoin blockchain, there will be a lot of technicalities, but I'm gonna skip them. Here I give you just the main idea. Okay, so let's get started. Since I want to keep this video simple and friendly to everybody, I will try to skip any mathematics, any coding. I just need you to understand what's a random function, so I will make an introduction, but try to avoid any kind of complexity in mathematics. The core technology that is used to generate a blockchain, so then also the Bitcoins, NFT, and whatever else similar. So this core technology is the file signature. Now, there is a bit of confusion in the market. Some people call it checksum, some people call it hash function, some people call it signature. For me, all of this is just a random number. You use a file as an input, and you get as a result a random number. I want to make sure that you understand this part, so let me give you an introduction to what I mean by random functions, so then you will understand everything else coming later on. It's nothing real complex. I will try to make it as simple as possible, but please try to understand this, because all you need really to understand to make a blockchain is this part. So here we are. To understand what I mean by random function, let me just remind you what is a function in mathematics. I will not ask you to understand really anything deep, but just an idea. So here I wrote this example where I put a bunch of ugly calculations. Don't even read this formula. It's just a mathematical formula. And the point is, you feed this formula with an input value, for example 4321, and you get as output 57.7. Now, if this function is what we call, mathematician calls smooth, derivable, and so on, continuous, then it means in practice that if you go to somewhere nearby, so I'm giving as an input 4321, and let's say I move slightly, so I go 4322, that's nearby, let's say, you will get a number that is somehow similar as output to 57.7, so it's kind of more or less intuitive, predictable. So for example, let's try, I move here the formula and we get 59.7. So, and then we might continue, given these two cases, so in 4321 you get 57.7, 4322 you get 59.7. So what can you get in 4323? Well, now you have two inputs, you can kind of intuitively say, well, it will be 61, 62, something like this. And actually, you are right. If we try, you see, we get 61.7. Now, this is what we call somehow a continuous and smooth function. We can also have a visual idea of this. Let's try. So here I created a chart where on the horizontal axis I put the input value and the vertical axis the output, and you see they sit more or less in a line, so makes this function what we call smooth, right? Let me make it more visible. You connect the dots with the line and you see, okay, more or less it's flat. Also, there is another point that I want to make you clear, that this function is deterministic. It means that if I compute a function in the same point, so I give the same input, I will get the same output. So for example, 4321 was 57.7, let's compute it again in the same point, and of course we get the same result. This is what we call deterministic. Now let's look at what we call random function. So it's still a function that is taking some input that generally we call seed and providing you an output. Now here I've wrote, don't read this, but some, not very good, but some random number generator. And you can see this number that is created will be between 0 and 100, and given this input we get 43. Now, since this function is random, it's not like deterministic, if I slightly move the input, change the input a bit, so I go 4322, I will get a completely different output. That's the core point of being random, being unpredictable. Okay, so let's just try. So, and we get 19. Now we might continue and try other places, so other inputs, so we can try 4323 and we get a number that is unpredictable, so let's try 95. Even if I give you a few inputs, you cannot get an idea what will come later. So, try to think a few numbers that might come, for sure you will not guess them, well, unless you're really lucky. And here we are. You see, completely unpredictable numbers. This is what we call random function. But still, we want this function to be deterministic. It means if we provide the same seed, so the same input, 43 to 1, we get 43. Let's try again, and we should get the same number. So it means this is deterministic. Let's try. Okay, and we get the same number. Now we can give a visual idea of this randomness, making another chart. So here we are. As you can see, we have these dots that jump up and down in a pretty unpredictable way. That's what we call random. Now there is another point I want to make it clear to you because it's really needed later on. This function is somehow in one direction. So give a seed, you get a random number. Going back, it's almost impossible, or this is what we really need later on in our video. So given 43 as an output, it should be almost impossible to guess that the input was 43 to 1. But just look at this. I give a number with 4 digits in input, and I get an output with only 2 digits, meaning I have 10,000 possible inputs, and I get only 100 outputs, meaning many different inputs will give the same output. Going back is basically impossible. We lose some information. Okay, just let me give you an example here. I go, and you see, when I give 4611, I get the same random number. So it's unpredictable, deterministic, and impossible to go back. This is what we need. If you understand this, then everything else in the video will be super clear. If you don't, please watch it again till it's real clear to you. We need a random function that is deterministic and impossible to go from the output to reconstruct, reverse engineer, call as you like, the input. Why this is so important? Well, we can use this to create signatures on files. Let's try. Here I have a bunch of files. As you can see, I have an image, a clip, a movie clip. Could be a contract written in Word, and some file in Excel actually is the file I'm showing you here. Anyway. And for example, a PDF document. Each file might be opened by a different software, so the Word document will be opened by Word, and the Excel file by Excel, and PDF by some PDF reader, and so on and so forth. But let me open all of them using Notepad++. I open these files in Notepad++ because there is a nice plugin that's here, and is letting me to observe the file as is written on the hard disk. So this is, for example, the PDF file, and here you can see that I can, for each, here there is the list of addresses in the memory, forget them. This is the file as it's saved in the hard disk. So 001, 00101, blah, 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 blah. And you see here, in principle, I can look at the file. Of course, it's very long, whatever. I can as well observe the Excel file in binary form, and that's pretty much similar. So, you have 01, 01, 000, and so on. The Word document as well. It's just 01, 01, 01, 10, whatever, here. Movie, doesn't matter. Of course, it will be much longer because it's a bigger file, but at the end of the day, it's still a list of 01, 001, whatever. Bitmap, the image. Okay, my computer is a bit crashing because it's heavy, but as well, a bunch of 01. So the point is, each file is just a list of 0, 1, 0, 1. So it's a number. Each file is a big integer number. Keep in mind this, because it's really crucial. Doesn't matter if you're looking at an image, if you're looking at video or document, PDF, Excel. At the end of the day, your file is a big number. So what's the idea? The really crucial idea. If the file is a number, I can use this number as a seed to generate another random number. So exactly what I did here, right? I take a number and I generate a random number using this as a seed. I can, in principle, do the same, considering the file as a big number, and generate a random number out of it. Why this is really important? The point is that the random number will be changing completely if you change a tiny bit in the file. Let's try, because I think experimenting makes it clear. So now it's time to use a 7-zip. If you're not familiar, you can just go to this web page, 7zip.org, and you can just download the version you want, you install it, and once you're done, you will get some extra tools. So when you go to your file explorer, for example, and you right-click on your file, you will get these 2 extra lines. So the first one is something you should be somehow familiar, is something to compress your files or to extract them. Fine. And then you get this second line. This second line is a tool that is letting you compute the signature of the file, or if you like, the fingerprint or the hash, something like that. So there are different names, technicalities, but okay, forget it. The point is you can compute a fingerprint, a signature of a file. Now, in what I explained so far in this video, the signature is just a random number. So let's try to compute it. For example, I use CRC64. And given this file, abstract.bitmap, that has a dimension of 6,000 kilobytes, something like 6 megabytes, we generated this string 09DC63 blah blah. So this string is a number written in hexadecimal. If you're not familiar with hexadecimal, forget it. It's just a number. Okay. So the point is, we used this list of the 01010111 blah 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 that is shown here as an input, and we compute a random number that's here. I lost it. This one. Okay. It's exactly the same as we did in Excel. I use this number as an input, and I get this one random number as an output. The input is the file. The output is the signature of the file, the fingerprint. Call it as you like. Now, why is it important that this is a random, but deterministic? So deterministic is because every time I want to compute the signature of a file, I want to get exactly the same result. Let's try with a different tool, for example. So there is this nice website where you can just drag and drop your files, right? And here there are different algorithms. So let's consider, for example, the SHA-265, 56, sorry. So let me just go here. So I can just drag and drop my file here, right? And this is computing the signature using this SHA-256. I can also try with my tool, 7zip, and here we are. Now you see this random number here. Well, wait a second, take a bit of time, it's a bit stuck. Anyway, I don't really know why this doesn't go away, but you can see this BD607 D79 blah 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 is there. BD60 D79 and so on and so forth. So it's deterministic. If I compute this random number several times, I will always get the same result. This is the deterministic. But now let's see the random feature. Okay, let's go back to my file. Let's say this is a very long list of 010101. In a random place here, I just substitute 1 bit. Okay. Okay, now this is 1. Before it was 0. In this extremely long list of bits. Let me save this file. A copy, of course. And let me call abstract2. Right. Well, this want to save it as text, but anyways, save it. Now, I created this abstract2 that is exactly the same file, but is just one bit that is different in an extremely long list of 6 million bytes. Let's compute the SHA, right? And we get 3E4C. This one was, let me compute it again because I closed it. BD60, blah, blah, blah. Let's compare these two. So I just change a single bit in a list of several millions, and the result is completely different. That's exactly what I meant random. Okay, so this computing a signature of a file is just generating a random number. Of course, there are different algorithms. 7-zip is providing this for I just discussed to you. You know this one, the CRC and the SHA. Okay, in 2 cases. This nice website is providing you a longer list with many. But okay, at the end of the day, that's it. I hope it's clear what a signature is. When you understand this, going to Bitcoin and blockchain is super simple. So now that the concept of signature is clear, at least I hope, we can start building the blockchain, actually something like the Bitcoin blockchain. So here I prepared the file that can be in principle a block of this blockchain. So it's just a balance sheet, or if you like a ledger, where, for example, a bank is just saving at the beginning of the day what's the balance in the account of several people, right? So Sophia is having 12,000 bucks in the bank, while Charles has a debt, has to pay 1,000 to the bank, Ethan has 230, and so on and so forth, up to Ellie, for example. This is the list of people. Of course, during the day, some of the people might make some transaction and decide to pay some money to some other people. So, for example, here we can add this column for each transaction. And, for example, Camilla decided to pay to Owen 100 bucks, while Emma decided to pay to Greece 50 bucks and to Ellie 100 bucks. Okay, so this is the list of the transactions of the day. And also we need a couple of extra info that I will explain you later, but pretty much should be super clear. So at the end of the day, we save the book, and we can also compute the sum, the signature of this file. So for example, we get this number. Now, I'm using Excel, but I don't really like to use Excel. And the point is, if now I open the file again, okay, and I make almost no change, but I save it. So I just, now Excel is saving C3 that is highlighted. I just click here, highlight A1. Let me save as a copy. But now I'm highlighting the cell A2. Before I was highlighting the cell C3. This is enough for Excel to create somehow a slightly different file. And when I compute the signature, it's already another number. You see, this is E1C blah blah, and this is 346. So in order to avoid this issue, because Excel is saving some internal stuff, let's use CSV format. So here we are. I have the day one CSV, and I can compute the signature, right? This one, and I can say the other one, sorry, this one CSV, where I just did highlight another cell, but you see the result is exactly the same. So I'm gonna use the CSV file for this reason. Let me just cancel whatever I don't need right now. So basically everything. Now, you can consider this file as the first block in our blockchain. A block in a blockchain can be seen like a file. As simple as that. A bunch of informations. Okay. Now, this was day one. Let me just go on and play, and let's say we go on day two. So let me save first of all this file as day two. Work out that, for example, now Camilla, since he paid 100, now is a smaller balance. Owen has a better situation. Okay, still negative, but better. Okay, let me remove this and do the same also for the other one. Okay, so on day two, this is the balance at the beginning of the day, and of course somebody might make some payment. let's just say Milan decide to pay $50 to, I don't know, Henry. Okay, let's make it simple, no transaction. Now, in principle, what I'm doing here is just saving a banking book, right, where we keep all the balance for all the people they have opened an account in the bank. So this is not a blockchain. To make this a blockchain, we need just a small step. Let's do it. I go here and I compute the signature of the file on day one, right? This is the signature. Let me copy this number. And what I do is basically here, I input the signature. So this is the signature of, if you like, the hash of, call it as you like, of the day one that now I'm putting on day two. Okay, this is the file day two. Okay, and we put the signature of day one. Right, now this will create a connection between the two files, because if for any reason somebody will modify the day one file, then the signature will be broken and I will notice in day two. We can iterate this process. Let's try just to create a day 3 and day 4. I will speed up a bit so you don't get bored. So this is somehow what we get after, for example, 4 days. We have 4 files that I'm listing from the left, the day 1, day 2, day 3, and day 4 on the right. And you see, in cell B2, I'm saving always the signature of the day before. Everybody can at any time check that everything is okay. So, for example, I say, okay, did anyone maybe change the file on day 2? Well, let's compute the signature on day 2 and we should get FE48 blah blah blah. Let's just try. So, for example, here on day 2 I have FE48 blah blah blah. That is exactly this one that I get on day 3. Okay, so what I'm doing by embedding as a sequence every day in the new file, I embed the signature of the day before. I create a chain of files. And if anyone will ever modify any file in the past, this will be affecting the full chain. This is what we call blockchain. Is, if you like, a bunch of files that they are connected by passing one to the other the signature. That's it. This is a blockchain. Nothing more complex. If tomorrow an hacker is just changing something, let's say, for example, on day 2, this guy is smart enough, Charlie, to modify his account and say, yeah, it become plus 1,000. Let's just do it. Right. So Charlie is smart, is just making a small change. Nobody will supposedly notice this. Okay. Let me now compute the signature and everybody will see that something went wrong. Now, the signature for the file day 2 is F1AD blah blah blah, while we should get FE485 blah blah blah. So, if later on you try to modify any block in the blockchain, this will spoil everything. So the signature is somehow a way to verify that nobody has modified anything. And when you embed in a chain of files, or if you like, a blocks, you build your blockchain. That's it. Nothing more complex than this. Now, let me clarify one point that most of the videos I see on YouTube, they mess up on this point. The fact you put many files in a chain and you build a blockchain doesn't guarantee any security at all. Because if this blockchain is on my computer, I am the administrator, I have the full control of this, right? So there is a central power, that's me in this case, that can do anything. Because if I want, I can just rerun all the files and change something and change all the signatures. You will not notice. The big step that, for example, Bitcoin did was to make a distributed blockchain, not just a blockchain, a distributed blockchain. So the point that everybody on planet can have this list of blocks and run on their own machine the checksum, so computing the signature to verify that nobody broke the blockchain. That's the key point, is distributed. Everybody has access to it. And trust me, many people, they lie on you because they say, oh, I build a blockchain, I have a startup, we make blockchain. Yes, but if the blockchain is on your private computer and you are the administrator, then it's a centralized power. That's not the big step that we got with Bitcoins. The big step is that is decentralized, is distributed. That's the key part, okay? It's not the blockchain itself, it's the fact it's distributed. Keep this in mind, because many people will try to cheat you. You were asking me, oh, should I invest in my money in some cryptocurrency? Well, first point, is your cryptocurrency distributed, or there is a central authority? Because if there is a central authority, it's exactly like going to the bank. Somebody can do whatever they want. Point number one, if you were asking me about suggestion how to invest. Anyway, to go and build the full blockchain like Bitcoin, we need another step. We need what we call mining. So, what's the mining? Basically, we need some people to physically compute the signatures and verify that everything is fine. So, we need to motivate them doing this work. I'm not doing this for free. Should I every day go in there and validate all the blockchain? Yeah, I'm not really in the mood, but if you pay me to do so, then I'm gonna do it. So that's the idea of mining. Give some reward to the people that do mining. How can you do mining? So now let's make a practical example how the mining works. So let's say we need to validate day 4, and we can compute the signature, right? And we get this one. Now, we might kind of do on our own computer, and I pass this file to you and you do the same time, and we make kind of a game. Can we somehow modify slightly the file till we get this signature starting with 0? How can we do this? Well, let's open the file, and you see there is a second field that I mentioned to you before, but I didn't explain. This field, mining tool. So here I set 0, and setting 0 we get this signature. Let me put here another number, say 42, and try to compute the signature. Now the file is different, I get a different signature. So let me save it, and now let's compute the signature for this different version of the file. I just change this. Now the signature starts with 9. Okay, I was unlucky. Let's try again. I put here 123. Save, close, and compute again the signature. Now the signature starts with C. So we can go on and try till we are lucky. As you can see, I'm trying many cases, and sometimes start with A, sometimes with 7, sometimes with D. So it's just trial. In principle, we might be doing this in parallel. So I'm doing this on my computer, trying different numbers, and you do on your computer. The first one that is faster in clicking and lucky at the same time, and gets some signature that starts with 0 is the winner, and is gonna win 50 bitcoins, let's say. Well, it depends on time how many you win. Currently you win 6.125, I guess. Not sure. But so basically that's the mining. You just slightly change the file till you are lucky, and the signature start with 0. 1, 0, 2, 0, 3, 0. Well, actually the algorithm is smart enough to set the difficulty, so the number of zeros, trailing 0 you need at the beginning. The number of trailing 0 is dependent on how many people are mining. When few people are mining, then you need a few trailing zeros at the beginning of the signature. When many people are mining, to make the game more complicated, you need more zeros. And on average is meant so then every 10 minutes somebody is guessing, okay? And making somehow the new signature, the winner. Of course, everybody has to agree at the end of the day, or if not everybody, because maybe somebody is trying to trick the system, at least the majority. So that's the way. We do in parallel this game of guessing different files till we get a signature starting with what we want, and the winner is gonna get a Bitcoin or few Bitcoins. So playing on this number. If, let's say, I'm lucky and I get it, then let's say Damiano, let's say at some point I'm lucky, I get 6.125 Bitcoins. Okay, that's it. This is the mining. Okay, some kind of a competition where if you have more computational power, you have more chances to win, but at the end you need to be lucky. So it's kind of random assigning whom is gonna get the reward, but you know, if you have much computational power, you have higher chance to win. This work is meant to do validation on this one. That's everything you need to know to understand Bitcoins. That's it, nothing more complex. Bitcoins is just a bunch of blocks, so if you like files where we save an account, we save the payments, and we save the signature of the previous block. So if anybody modify a previous block, then the blockchain, everybody can see is broken. And we modify the last one by this game of mining, so basically guessing till we are lucky and we get some signature with the trailing zeros at the beginning. That's it. Okay, now we built our distributed blockchain with all the mining, so it's safe, it's almost impossible to hack. Well, in principle it's possible, but in practice it's not. So when we have our Bitcoins, Bitcoins is just a bunch of numbers assigned to a bunch of users, but that's it. We can do more, and that's actually what we do, for example, with Ethereum or NFT. And what's this more? So instead of just saving on a specific user the amount of money, we can also say this specific user is owner of some files. Let's see an example. I'm a scientist, I've written my genius idea into paper, and I'm scared that somebody tomorrow might come and say, oh no, I got the idea before. This is one example. Or for example, we write a contract, me and you, and I'm scared that tomorrow you might change something in the contract. So I want to make sure that the contract that is written today will be saved and nobody can change it anymore. Okay? So the blockchain is very useful for this. Let's consider the files I showed you before, so the contract and my genius idea, and I can compute for them, okay, the signature for both of these files. Now, why not adding these signatures here below, as I did here, right? So Damiano is owner of these two files, and this is the signature. If anybody makes any change, the signature will be broken. But also, this is saved, for example, in day 4, right? So I can prove that on a specific date, I was having this file on my hands. If you come later, I can go to the blockchain and say, no, this file was mine on this date. This is something, basically, we do with Ethereum. So it's a way to secure some files, some ideas there. And of course, we can easily go to the next step, but this is NFT. Let's say now I become an artist. Cool, I'm an artist, now let me take a color that only my artistic heart can take it, and this brush, and I paint this one, okay? This is my love for you all, people. Yeah, Damiano's art. Well, let's make some background, I mean, just to show that I'm cool in using this tool, and here, let's put it this one. So let me save this file, it's so important, such a big contribution to the human artistic features, whatever, and I want to save it as an NFT, so save the file. Here we have our file, and I can compute the signature and add to the blockchain, right? So as you can see here, I have the signature on my name for this file, so basically we can call this NFT. Now, if anyone, let's say an hacker, is wanted to copy my file and pretend that it's belonging to him, you know, let's say I go here, for one day I'm showing you the file, and you are a smart hacker, so you take just a screenshot, like this one, right? And they take a screenshot of the file and say, oh, look, it's the same, let me save it as an hacker. And now I will save this file with a similar name, but I will say Damiano's art, true, original. Okay, so the hacker made a copy of my file. Now, if we go here and we compute the signature of this file, we will get a different number. Right, this is 2E22, say the true original, fake. 2E239 whatever, we go here, no, this is B3577 and so on. So you see there is a way to prove that a certain file was exactly the original. Anytime change will of course change this random number, or if you like signature, fingerprint, hash, whatever. I mean, there are several names. Right, so when I insert this one as well, I'm basically doing this NFT. Let's look at Wikipedia if you don't trust me. What is NFT? It's a record on a blockchain. Okay, a record is just a line. This line is a record in a blockchain, right? Which is associated with a particular digital or physical asset. That's it. Okay. So there is nothing complex there. I mean, I see so many videos, they make it, no, we're done. The video is over. That's it. Well, the video is over. I finished with explanation, but still I promised you to share my opinion about investing in Bitcoin, cryptocurrency, NFT and so on. So let's do it. So let me give you first an example. Try to think you want to sit at the table and play poker, and you are not really familiar with the game. Okay, you know more or less the rules, but you don't really know all the rules in details, all the exceptions, and overall you don't even know the strategies how to play properly. And now you sit at a table where everybody is professional. So there is world champion here, super champion there, and so on. Do you think you are gonna win the match? Okay, maybe you are lucky, and even though you are a beginner, you can beat the super champions, but okay, the chance is really low. Actually, it's basically zero. The same holds if you try to play trading with the bitcoins, for example. What I explained in this video is a simplified version. There are many technicalities I didn't explain because I wanted to go to the core of the problem. But if you don't understand everything and you play against people, they are professional, they know much more than you, it's almost certain you're going to lose your money. So the overall suggestion I can give you is if you really want to trade, doesn't matter what, I will suggest you first of all invest your time. Invest your time to learn and to understand. Invest your energy to study, to look around, to understand everything. When you are really expert and you really understand everything, then you might start trading a little amount of money. Because even if you study everything, you don't have the experience. So if you play with a really little amount of money, something that you consider already lost, okay, you are gonna lose this money. It should be an amount that doesn't change your life in a negative direction. So you can use this small amount of money to learn a bit, and then you will see you lose. But if you can win, then okay, go. Okay. But my first advice, if you want to invest, is invest your time and learn. Okay? Good luck.